Today we are going to look at something very, very important in current electricity. Today we are looking at galvanometer conversions. Galvanometer can be converted to ammeter, and galvanometer can be converted to voltmeter. Let me start with conversion of galvanometer to ammeter.
Welcome to today's class.
Galvanometer can be converted to ammeter using a low resistance shunt connected in parallel. Once you connect a resistor known as shunt in parallel to the galvanometer, you have ended up converting that galvanometer to an ammeter. Now, the question can come like this: for you to find the resistance through the shunt or the resistance through the galvanometer, or let me use Rg as resistance through the galvanometer or resistance through the shunt. Let's do it this way. This is the total current. Once it gets to this junction, it will be divided into two: current that will flow through the galvanometer and current that will flow through the shunt. If the total current is I, the current that will flow through the shunt will be I minus the one flowing through the galvanometer. This is the one that will flow through the shunt. In this case, we'll have it that potential difference across the galvanometer will be, remember, potential difference V is I. Potential difference across the galvanometer will be IGRG. Remember, V is equal to IR. This is the potential difference across the galvanometer. Then potential difference across the shunt will be I minus IG times RS. I minus IG times RS. So the next thing we are going to do is, because they are connected in parallel, you see they are connected in parallel, they have the same potential difference V. Therefore, potential difference across the galvanometer IGRG will be equal to the potential difference across the shunt. So we can get the shunt resistance to be IGRG over I minus IG. Please write down this formula. Let's take this example. The diagram below illustrates the conversion of a galvanometer of resistance 2 ohms to an ammeter. The galvanometer gives a full-scale deflection for a current of 10 milliamperes. Calculate the value of R. Let's write out everything we are giving. Giving the total current I as 10, the current through the galvanometers as 10 milliamperes. Milli is 10 raised to power minus 3. The resistance through the galvanometer is 2 ohms. We are looking for the shunt resistance. So using the formula, please always write the formula so that you get mark. IG RG I minus IG. Please always write the formula. IG is 10 times 10 raised to the power minus 3 times RG is 2. I is 10 minus 10 times 10 raised to the power minus 3. So let's go ahead and solve it. That will give us 0.02 over 9.99. And then our final answer will be 2 times 10 raised to the power minus 3 ohms. A galvanometer can be converted to a voltmeter by connecting a high resistance multiplier in series. It must be connected in series such that the current that flows through the galvanometer is the same current that flows through the multiplier. Remember, you can be asked to find the current through the galvanometer or the resistance of the multiplier. In this case, the potential difference across the resistor is V1. The potential difference across the galvanometer is V2. Each of them have different potential difference. So we can now have the total PD across the circuit. The total PD across the circuit will be V1 plus V2. So that total PDV is equal to, remember, for V1 we have IGRN plus for V2 is the same current IG that will flow through the galvanometer, then RG. So V is equal to, let's factor out IG so that we'll have the multiplier resistance plus the resistance through the galvanometer. So that if we divide both sides by IG, we'll have V over IG is equal to RM plus RG. Let's take this one to this side. V over IG crossing over is minus RG is equal to the resistance for the multiplier. The resistance for the multiplier. So we can use this formula to solve for the resistance of the multiplier. Let's take this example. A moving coil meter with an internal resistance of 100 ohms has a full scale deflection when a current of 10 milliamperes flows through it. What value of resistance would convert it to read 10 volts at full scale deflection? Giving internal resistance as 100 ohms, current 10 milliamperes, V is given as 10 volts. We are looking for the resistance of the multiplier. So which formula are we going to use? Remember the formula we derived, that Rm is equal to V over Ig minus Rg. Please don't forget it. We'll go ahead and have our V to be using Rm is equal to V over Ig minus Rg. So we have it to be V, which is 10 over Ig. If you convert this, you have 0.01 amperes minus Rg. Rg is 100. So this will go further to give us 1000 minus 100. Our final answer will be 900 ohms. Okay, try this for the community practice question. A galvanometer has a resistance of 5 ohm. By using a shunt wire of resistance 0.05 ohm, the galvanometer could be converted to an ammeter capable of reading 2 amperes. What is the current through the galvanometer? A. 2 milliamperes, B. 10 milliamperes, C. 20 milliamperes, D. 25 milliamperes. And also try this community practice question 2. The maximum permissible current through a galvanometer G of internal resistance 10 ohms is 0.05 amperes. A resistance R is used to convert G into a voltmeter with a maximum reading of 100 volts. Find the value of R and how it is connected to G. A. 20,000 ohms in parallel. B. 19,900 ohms in series. C. 1,990 ohms in series. D. 100 ohms in series. Please try the community practice question and do well to vote for your answer. Like, subscribe, share, and turn the bell notification for more videos. Thank you.